Hey, welcome back to the Caribou Data Science channel. This is the evening of Tuesday, January 3rd. We're going to continue this evening with the WorldQuant University's data science workshop. Tonight we should be able to finish the exercises. Maybe move on to doing look at the first assignment that remains to be seen. But sit back, relax. We'll be back with you folks in 15 minutes. Okay, so this didn't record because it had a time on. This is the evening of January 3rd, 2023. Welcome back to the Caribou Data Science channel. I'm going to continue to try to. Our plan for tonight is to finish the uh, exercise portion of the data science lab for World Quant University. I was mentioning that World Quant University is completely free. Completely free. You no beggarware, no nothing. All you have to do is pass a very simple interest quiz. I passed it, so you can pass it. Consists of what 4 or 8 different modules, maybe 4 modules, 8 modules with 4 exercises each and an assignment. So we'll be back to you folks in 15 minutes to pick up where we left off last night. And God, God, uh, This is what Adonai, God of salvation, will say. How long will you refuse to humble yourself before me? Let me let my people go, so that I may serve them. But here there are legal definitions, legal terms. Those are predefined. The question is, did that understanding of arrogance actually, he may not have been, he may have been he may not have saw. Remember, Israel were not independent. They were relevant. He didn't go from one place to another. He went from one state to another. In order for the Roman Empire may not have made it, the most common reference is that the Roman Empire, Roman officials taught us to put more. And nobody's to yes, well, yes and no. I mean, God, the only one who went to Egypt was his family. They weren't clothed them, and they weren't food. They really, this is only one. We normally refer to a group of people, individual. Most of them, this is what the God of heaven said. As long as you refuse to humble yourself, let my people go to them and serve me. And else, if you refuse to let my people live, beginning tomorrow, I will bring the locust into your land. Then I will cover the face of the earth, so that no one will be able to see the ground. They will eat the remainder of the ground and let it see, whenever it left their hand, and eat every tree that grows from you in the field. Their horses will be filled, as well as the houses of your servants. Filled, as well as the houses. The houses will be filled, as well as the house of your servants, and the houses of all the Egyptians. As neither your fathers nor your grandfathers have seen since the day when they were on the earth until the day. Then he turned without thinking further. Pharaoh said, how long will this man be a servant to us? Send the men so they can serve Adonai their God. Don't you realize that the Egypt is being destroyed? So Moses and Aaron were brought back to Pharaoh and go serve Adonai your God, he said. But who will we bring? Moses answered, we will go with our young and our old, our sons and our daughters. We'll go with our flocks and with our herds. Then let's offer Adonai a feast for him. But he said to me, so may Adonai be with you, if I ever let you go with your little one. See clearly now, evil in your face. Not so. Go now, lament and serve Adonai. What you are seeking, then he will give it up with your praise. Then Adonai said to Moses, stretch out your hand over the land of Egypt, for the locusts as they come up into Egypt, and eat every plant in the land, everything Okay, here we go. This is size or location, which is more important. So as you can see, we're probably going to be working with some visualizations here. Let's see. Location or size, what influence houses most? Just come over here. Nothing tricky here. We continue to use this here in order to play inline. What this does here, I guess, this allows us to actually display videos inline, okay, without popping up a window. Let's just come at you. Let's just load our libraries as always. Here we go. You wrangle the data. You gain the understanding of the basic characteristics in your EDA. And now it's time to ask some research questions. Let's begin by, and let's do this. Okay, first question. Which state has the most expensive real estate market? Let's do one more thing over here. Let's go back to GitHub. And we'll continue to add to our command summary, okay? Also, in the link to this video, you'll see a link to this file, this directory over here with my summary in it. So you can certainly go out and download that for your own use. Now, research question 1, which state has the most expensive real estate market? Okay. Do housing prices by state? Do housing prices vary by state? If so, which is the most expensive states for purchasing a home? During our exploratory data analysis, we use descriptive statistics like mean and median to get an idea of the typical house price in Mexico. We will now break that circulation down by state and visualize the results. Let's come down here.
Our first research question is, which state has the most expensive real estate market? So the next couple tasks we'll be doing will be to calculate and then communicate that information. Let's dive right into the notebook here. And I'm going to go right down to task 2, mean price per state, and I'll zoom in so that we can have a...
Okay, let's come over here now. Let's just go ahead and start off our day right over here. We're going to begin with and 0.
good idea of, what I'm doing. And we're going to do something here called method chaining, where I'm going to start with just the data frame, and then slowly I'm going to add different methods onto this so that until we get the information that we want. And then just down below, so we kind of can follow the work we're doing, I'm going to copy and paste mean price per state so we can see the output. Now, the first thing we're going to want to do is we're going to want to do group by, and we want to group our data by state. So I'll use state here in inverted double commas. And if I hit Shift and Enter, we're going to get something that is not readable to us as humans, but this is another example of kind of an iterator object. So something we can kind of step through if we wanted to write like a for loop, But in this case, we actually are not going to do that. We need to do a little bit more work to kind of get the piece of analysis that we want. So that means we need to chain another method onto this. So we had the group by method first, and then we're interested in the price, right? So I'm going to use square brackets, and I will put, let's see here, double inverted commas, and inside there I'll put price USD for price USD. That's going to give me the same thing. I'm not going to see anything new yet, because what I need to do now is I need to begin aggregating, right? Because we have these groups, we have each state, we have the price USD column. Now we want to kind of combine those for each state, and we want to get the average price or the mean price. So the method we're going to tack on there will be .mean. If we do that and hit Shift and Enter, get ready for this. There's going to be a lot of output. Are you ready? Boom. So what we have here is we have a Pandas series. And if we take a look at this series, what we can see is that on the, let's see here, we have the index. The index is named state, and then the labels for each of the rows in this index are the names of the states. And we can see that they are alphabetic all the way from Aguascalientes at the beginning to, you can't see this, it's off the screen, to Zacatecas right at the bottom. And then for each of those index labels, we have an associated value. And that value is the mean home price in each of those states. And one thing we can see is like there's definitely a difference in terms of the mean price per state. Like, we can see it's 110,000 for Aguascalientes, but then it's down to 78,000 for Durango. But it would be much easier to interpret this if it was actually sorted not by alphabetically by state, but by the value, the mean home price. So let's rework this a little bit. Let me clear these drawings, and let's go back up to the code. Here we go. So the next method that I'm going to tack on here is going to be sort values, and I'll hit Shift and Enter. And now things are getting a little bit more interesting. We have the lowest mean price for the state of Oaxaca, and then it goes all the way up to
Okay. Reinstate. Right. Okay, good. Okay, so we're going to jump down here. Calculate mean state. Okay. So,
Here we go. So the next method that I'm going to tack on here is going to be sort values. Sort values.
So do we come back up here and that?
And I'll hit Shift and Enter. And now things are getting a little bit more interesting. We have the lowest mean price for the state of Oaxaca. And then it goes all the way up to or down to whatever direction you're thinking to Querétaro, which is around 133, 140,000, 134,000. Now, the instructions state that we want this to be sorted from the highest to the lowest mean price, and we're actually sorted lowest to highest. So we're sorted ascending. We want this series to be assorted descending. And in order to do that, we need to add an argument here in sort values. There's an ascending argument, and we want to set that to false. So if I type in all of that and hit Shift and Enter, we should see Querétaro at the top, and here it is. And it will go all the way down here to the bottom to Oaxaca, which is at 59,000. Beautiful. So now we can see that.
Wait. ASCEND. Huh. That's interesting. Hmm. Interesting. Hmm. I shouldn't have changed any of the prices. Okay, this is kind of strange, but you know what? I'm gonna go ahead and go with it. The code is correct. This simply means that the data there's a problem with the data for some reason.
Yes, indeed, there are definitely differences in the housing prices in each state. The next question we need to ask ourselves is this the most elegant or kind of easy way to communicate this data? Maybe there's a way that we can visualize it. So let's think about that and we'll move on to the next task.
Bar plot.
All right, we've made this beautiful series where we have the mean house price for each state in Mexico. The question is, how can we visualize this information so that it's accessible to people who aren't as, data science inclined as you and me? So what do you think would be a good way to represent this data? I'm going to do like you remember the kids' TV where they're listening? Well, if you said bar chart, you're absolutely right. A bar chart would be a great way to do this. Now, before we dive into the notebook, I just want to draw your attention to something. Up until now, we've been using the matplotlib library to do our visualizations. But did you know that you can also use the pandas library to do visualizations? Now, why is that? That's because there are a lot of matplotlib tools that have been brought into the pandas library. So what does that mean? That means that you can use pandas for a lot of your plotting, but you can use a lot of the tools and techniques you've learned about matplotlib, a lot of the arguments and thinking. You get to use those in pandas as well. So all of the work we've been doing with matplotlib will definitely be helpful as we use pandas directly. So just keep an eye on that. Now I'm going to go into the notebook here, and we're in task 3, and we want to create a bar chart of our mean price by state. And so I'll just start with the series that I want to plot. And when you want to create a plot with pandas, I can just take that series and then put a dot and then plot. And if I hit Shift and Enter, it actually gives me a line plot. Now, this is not what we want. This doesn't make any sense at all. So we're going to need to do a little bit of work here. So let's see here. We have a lot of arguments that we need to put inside this little plot method. And so I'm going to put a return in between those two parentheses and just indent for readability's sake. And the first thing that I'm going to do is I'm going to say kind. There's a kind argument, and I'm going to set that to bar. So I'm going to set that to bar, and then I'm also going to put a semicolon after the close of the parentheses so that I get a good, I can reduce, there's no output. So I hit Shift and Enter, and now things are looking very nice. I can see that I have the states along the bottom, and I have the prices along the side. Now, one thing we're definitely missing are our axes labels. So let's add those. I'm going to scroll up here, and instead of, previously, the way that we would do this is we would do PLT X label, and then I would put in the name of the label here. I don't need to do that anymore since I'm using Pandas. And what I do is I take those same ideas and I put them in as arguments. So my next argument is going to be X label, and I'll set that equal to state. And then after that, I need Y label, and I'm going to set that equal to price in USD. And then last but not least, I need to put the title, and this is going to be mean house price by state.
Yeah, but you know what? We really need to flip this on its side, I think. Let's come back up here and see what the grass was.
Beautiful. So then I'll hit Shift and Enter, and oh dear, I got a syntax error. Let's see here. Let's unpack this. So if I'm looking at my syntax error here, syntax error, invalid syntax, and it's pointing to line 5 of my code, which is this line right here. Now, you might think that there's a problem with this.
Now, normally in most languages, this means this is where it stopped, which means that the error message, he's going to say this, this means that the error message can occur anywhere above that line. Okay, let's see what he says here. I just made the same error.
Line of code, but in fact, that's not the case. Can you see what the problem is? Can you guess? You're probably shouting at the screen right now. We're missing a comma in the previous line. So it's kind of spilling over to the next line, and that's why we're getting that syntax error, and it's pointing to the wrong line. So oftentimes when you get these syntax errors, you need to not only look at the line in which you get the error, but also around, maybe in the previous line, to see if it's there as well.
So let's just try some here. The question is, can we flip the report vertically? To flip the plot, you can use the X label. That's interesting. Hmm. No, it didn't work. Oh, flip the labels, but not the price. Well, that didn't do you good. I wonder if there is a vertical option. How do we spell horizontal? Horizontal. Okay, now this is really strange. I have no idea We'll see. Hopefully he'll sit there and he'll. Well, maybe he'll come up here and he'll tell us how this.
Or if it's there instead. So with that in mind, let's clear these drawings and let's put in that comma where it should be. And now the code should run perfectly. And indeed it does. Let's scroll down and just look at this plot a little bit. So what do we have here? We have on the one hand, we have all of the states along the x-axis. And then along the y-axis, we have the prices. And we can see that general move from most expensive to least expensive state, from Querétaro down to Oaxaca. So this really gives us a good way of seeing what are the kind of most expensive and least expensive states when it comes to real estate in Mexico.
It seems odd that Guadalajara would be the most expensive real estate in Mexico, but according to the recent GDP numbers, it's not in the top 10 in terms of states' economies. With all the variation in housing sizes across states. A better metric to look at would be price per meter.
Numbers are very helpful. Hey, I'm a data scientist. I love numbers. But one thing that can be especially helpful when you're doing this sort of analysis is to have some domain expertise or to work with somebody who has domain expertise. You know, they bring the domain, you bring the numbers. So one thing that seems odd to me is that the most expensive state in terms of mean property price was Querétaro. And if I go to my web browser here, I have a page open from Wikipedia. And if we scroll down, it says Querétaro has the 16th biggest state economy in Mexico City, way behind the state of Mexico or Mexico State, Nuevo León, Jalisco. And so it seems strange that a state that's not even in the top 10 in terms of GDP would be the first in terms of property prices. Now, when we see this kind of disconnect, one thing that can create this would be the size, right? Maybe the houses in Querétaro are very big and the prices reflect that. But in Mexico City, that's more dense. They might have, smaller houses and a higher price per square foot. And so a good way to compare these is precisely to look at price per square feet. So let's do that. I'm going to go back to our notebook here and I'm going to zoom in and let's do price per square feet. So let's create a new column onto our data frame. So it's going to be the price USD, and it's going to be divided by df. It's going to be divided by area. And before I hit shift and enter, let me also just do df head here so that I can check and see my work is actually working. So I'll hit shift and enter, and we can see now that I have area, I have price USD, and now I also have price per square meter. Okay, this is very helpful, and let's take this information with us when we go into the next task. So it's going to be the price USD, and it's going to be divided by df. It's going to be divided by area, and before I hit shift and enter, let me also just do df head here.
Now, here's the thing. We're going to be using these commands over and over again, okay? So that's mainly why and my short-term memory isn't that good, so that's mainly why I'm making all these code notes here. No group by plus bar chart. Okay.
Now that we've calculated the price per square meter for all of our properties, we're going to do a very similar aggregation and visualization as we...
You know what? Let's just have a bit of fun here, shall we? So we got this. Let's just create some descriptive statistics for this number here, shall we? The average price per square meter is $735 and change. Standard deviation is 416. Minimum is 175. Maximum is 806. Okay, good. Never hurts to do a little bit of.
We did with the mean price per state, except this time it's going to be mean price per square meter. So we're going to use a group by to create the series, and then we're going to use that pandas plot to create our plot. And whereas before we did that in 2 steps, make the series and then make the plot, we're going to do it in 1 step here. So it's going to be a lot of method chaining. And
Okay, let's try it. Let's try it one more time. Oh, now this is interesting, isn't it? Hmm. Oh, okay. Let's continue on here.
And we'll go through the syntax step by step. So don't worry if you're just like, oh my gosh, look at all this code. It will begin to make sense. Okay, so let's dive right in here. I am here and let's zoom right in. And the first thing that we want to do is we want to create our group by, right? So we're going to do df.groupby, and we're going to want to group by state. Beautiful. And then the other thing that we're going to want to do is we're going to want to look at not price USD, but rather price per square meter. And we're going to want to look at the mean. Beautiful. Let's hit Shift and Enter just to see if this gives us what we want. And indeed it does. We can see that it is sorted alphabetically by the index, starting with Aguascalientes and going all the way down to Zacatecas. All right. Now, there are a couple things that we want to do. We definitely want to sort these. And you know what? This line is getting pretty long with all of this method chaining. So why don't we do the following? I'm going to take all of this code, I'm going to highlight it, and then I'm going to put some round braces around it.
Why?
So that it's, kind of packaged. And then I'm going to put it on its own line. And putting these parentheses around the whole thing is going to allow me to break up this line into multiple lines so that we can basically see step by step what we're doing with the data. So we start with our DF, we then do our grouping by state, and then we get the mean price per square foot for each of those states. Now, the other things that we need to tack on there, we need to sort those values. And like we did it before, we need to make sure ascending equals false. And then, is that all we need from this particular thing? I think so. Let's just see if this is what we want it to look like. Yeah, this looks good. So here we can see that the federal district, or the capital, is by far the most expensive. And we can see that Querétaro is now much lower in the scale. So that's beginning to make sense to us. Okay, so we have our series. This is working.
Hmm.
And like we did it before, we need to make sure ascending round braces around it.
Hmm. Okay, there's something screwy here. This is interesting. Wow, what the devil happened? Wow. Okay. Ah, man, that's interesting. My guess. See, here's the trouble. It would appear, well, no, because I'm using my clean data set, right? Hmm. That certainly was screwy. As always as someone, here's the thing. Every student should have their own copy of the data. They shouldn't be overwriting people's data.
So that it's, kind of packaged. And then I'm going to put it on its own line. And putting these parentheses around the whole thing is going to allow me to break up this line into multiple lines so that we can basically see step by step what we're doing with the data. So we start with our DF, we then do our grouping by state, and then we get the mean price per square foot for each of those states. Now, the other things that we need to tack on there, we need to sort those values. And like we did it before, we need to make sure ascending equals false. And then, is that all we need from this particular thing? I think so. Let's just see if this is what we want it to look like. Yeah, this looks good. So here we can see that the federal district, or the capital, is by far the most expensive. And we can see that Querétaro is now much lower in the scale. So that's beginning to make sense to us. Okay, so we have our series. This is working. And now, since this is a series, the same way that we tacked on the dot plot method, we can tack on the dot plot method here as well. So I'm going to hit enter and do dot plot. I'll open up this parentheses and close it. And I'll also actually put a line break in there so we can put all of our arguments together. And I'll do kind equals bar, like we did before. I'll set the X label to state, like we did before. I'll set the Y label to, let me just grab this from the instructions,
Hmm. Interesting. Oh wow, I forgot to sort values. Oh, I know what the trouble was. I didn't have.
mean price per square meter. Beautiful. And then the last thing, but not the least thing, is going to be the title, which I'll also grab from the instructions and just copy it, paste it right here. Excellent. And then I will add that semicolon right at the
Hey, Jay, how you doing, friend? Thanks for stopping by. I didn't hear you come in. Yeah, I'm working on this is what's called WorldQuant University, and this course here, which is like a four, it's like a has like four or five, six sections to it. It's completely free. It's all Python based. It's completely free. All you have to do is pass a simple quiz, a mission quiz, and I passed the quiz. So that's it. I mean, there's no beggarware, there's no nothing. It's just this free thing. And because videos and assignments, we can find you a thing here. Yeah, here's the main site. So if you're looking for some experience using Python, I would at this point I would certainly recommend it. I would certainly recommend this site here because it is completely free. Let's just do something here. And I'm also what I'm doing is I'm actually creating a cheat sheet, okay, of all the commands I'm using in this course, module one of this course, okay, all this code here. Uh, and if you're interested in look at my code, look at the description of this video, you'll see a link to this page here, okay? What I'm trying to figure out is how do I get back in here and okay, okay. What I use with I use what's called Git, which is a source code management GitHub, which is source code management. So now I just downloaded the latest version of this thing here. And I see I left out 1.4.5, so we're going to start at 1.6. So I'm going to do something a little crazy like this here. So tell me, Jay, what are you up to this evening, huh? And you'll notice I'm using a very simple markdown language here, okay? A very simple markdown language. So I'll make my changes here. Then I can just upload them to GitHub then. So our question is there a relationship between home size and price? This is the housing price information uh, for Mexico. Okay, and each section includes four or five different sections. With each one has a video, and you do a couple, and you just come and type in a few commands here. Okay. Tell you what, hold down the fort, I'll be back in just one moment. Uh, so what are you up to this evening, Jay? I'm having a piece of mincemeat pie. As you can see, we're using Jupyter Labs notebooks. You got data, you got images, and then you have the section, the various you're going to do. Now I'm on the last exercise, then 015 is an assignment. And by the way, Jay, be sure to hit that subscribe button, the like button, and click that bell icon next to the subscribe button. I'll be notified whenever I go live, okay? My general plan is Monday through Thursday, 8 p.m. Eastern Time, that's New York time. Uh, I do a live stream. Sometimes I'm on Sunday, but if you click that bell, whenever I go live, you'll be notified, okay? So, from our previous question, we know that the location of the home affects the price, its price, especially if it's in Mexico City. And what about the home size? Does the size of the house influence price? Well, of course it does. The question is this: does the price per meter go up as the size of the house goes up? That's an interesting question. A scatter plot can be helpful in evaluating the relationship between two columns because it lets you see if the variables are correlated. In this case, if an increase in the home size is associated with an increase in the price. You come down here, the video, highlight this square, do a shift enter. That should give us the video then, okay?
They say that the most important thing in real estate, the three most important things, are location, location, and location. Now, we can definitely see in our previous research question that, yeah, location is really important.
Yep, that also applies to business, right?
For example, if your house is in Mexico City or the Federal District, that means it's going to be a lot more expensive when it comes to price per square meter. But another research question which I would like to ask in this lesson is there a relationship between how big a home is and how much, what its price is. And so let's focus on that. And the way that we're going to investigate this first is we're going to create a scatter plot. And what we're going to be doing is along the x-axis of our scatter plot, we're going to have the home area, and then along the y-axis, we're going to have the home price. So essentially, we're looking at home price as a function of the size of the home. So enough of my pantomime. Let's go into the notebook here. So looking into the notebook, let's zoom in and let's begin making our scatter plot. Let's see here. So we're going to be using matplotlib this time, not pandas. So I'll do plt and then I'll do scatter. And inside scatter.
Now remember, correlation does not mean causation. Okay, that's the only thing you have to know about statistics. Correlation does not mean causation.
Scatter, there are two arguments that I need to provide. One is x, what's going to be along the x-axis, and in this case, it's going to be what did I say? Area. Hold on. Area, there we go. And then the second argument is y, what goes along the y-axis, and in this case it's going to be price USD. Beautiful. And if I just quickly plot that out, we can see that, scroll down here, this is looking good, but of course we need to label all of our axes. So let's begin adding those. I'll start with PLTX label. And so this would be area in square meters. Beautiful. Then next I need to put in the Y label, and that's going to be price USD. So price USD. And then last but not least, I need to put in the title. And the title is going to be, let's see here, let's call it price versus area. And let me just draw your attention to one thing. Notice here that the thing that we're looking at along the y-axis, we're listing that first. So y-axis, price, and then we separate it with verses, and then on the other side of the verses, we have area, the thing along the x-axis. So first you put the y-axis, then you put the verses, and then you put the x-axis. Last but not least, let's put in a little semicolon here. I'll hit Shift and Enter, and now I've got a pretty good plot here.
Not really.
Now, what do we see in this plot? Let's unpack it a little bit. So looking at this plot here, it does seem that there is kind of like a general trend whereby the more, the bigger you...
So, scatter plot. Now, I'm going to use a slightly different format, which I think is easier to read, okay? X equals okay, right, comma, data equals, see what I did there? X label. Y labels what? Okay. Well, that's interesting. So how do we, well, see, here's the question. Apparently there isn't an easy way in Matplotlib to add a regression line, okay? Or another line even for that matter, okay? So let's come over here then. Wonder why this is different. Let's see if my code works here. Will this work? There we go. Now, yeah, there does seem to be a pattern up here, but let's just come back over here.
Your house is, or as house size increases, so does house price. And that intuitively makes sense. You know, the bigger the house, usually the more you charge for it. So as area goes up, so does price. Now, there's a lot of stuff in this plot, which is like, it's not exactly consistent. It's not a straight line. I got a lot of stuff up here. I got a lot of stuff down here, but there seems to be some sort of general trend. Okay. Now, looking at this plot, is there a relationship between area and price? We could say yes in terms of passes what we call in statistics, sometimes this is called the ocular forehead test. And it's like this. You look at the plot, and then it hits you in the forehead because it's so obvious. But it would probably be better to do something a little bit more systematic. So maybe there's a way to represent this numerically. So that's what we're going to be looking at the next task is how do we represent this relationship between these two variables numerically?
I'll just point out here, since you may not do it. When I did a search on the chat AI site uh, to add, how to add a regression line, trend line to the data, it wasn't like, oh, you just go down, you add, you know you know you used to go you just go down, you add lm dot plot or something like that. Um, but here's the question: is there, suppose instead of uh, suppose instead of so what we want to know is, yes, of course the price is going to go up because the house is bigger. But the question is, does the price per meter go up as the house gets bigger? That's the question. I think it's actually meter square, but that's okay. We are getting close down here also. Now, I don't know if you're a Python programmer, but if you are, and you're familiar with the Seaborn package, you actually have, I think it's called a reg plot function, which is actually designed to plot this, which would plot this with the regression line overlaid. Uh, okay, let me see. What we want to know is we want to know if the price. Oh, now this is interesting, isn't it? Now this is interesting. According to this, as the size of the house goes up, the actual price per square meter remains flat. Now that, my friend, is a very interesting, which which is a good sign because it means regardless of the size house you're buying, you're going to wind up probably if the house is over say 150 square meters, you're going to wind up paying the same price as you would for even a larger house. Although it's interesting that the smaller homes, okay, actually charge more per square meter. Okay, so you want to buy a house at least 200 square meters in Mexico. Okay, interesting. We can You can see even with this, most of the homes are still clustered down here, but under say $1,500 per square meter. All right. Well, there's a good amount of variation. There's a definitely a positive correlation. I would say this is a negative correlation because as the size goes up, the price per meter goes down. Hmm. The old Pearson's correlation, 147. So let's see what this has to say. The old Pearson's correlation.
We saw that there's a relationship between the size of a house, its area, and how much it costs, its price. We saw that visually, but is there a way to represent that relationship numerically? The answer is yes. It was a rhetorical question. And the number that we're going to use is something called a correlation coefficient, or, if you want to be fancy, a Pearson correlation coefficient. Now, before we look at how to calculate it, let's just put it into context. Let's put that number into context. So I'm going to go to the scatter plot, which we just created, and I'm going to zoom in. And the thing that you need to keep in mind with this correlation coefficient is that the correlation coefficient is going to go between -1. This is actually, they represent it using a little r. It doesn't matter, but we'll just use a little r here. And it can go all the way up to 1. Now, what does that mean? Well, if we had a 1, it means we have a very strong positive correlation. All of these little dots would basically be following that orange line, which is to say, as soon as area increases, price will increase in a very predictable way. So that would be 1, very strong correlation. -1 is kind of what you think it would be. It would be the same thing, except now it's going negative. So as area increases, price would decrease. And a -1 means that they would all be lined up along that line that I just drew, all of those data points. And then a 0 means there's absolutely no correlation at all. And we would basically just see dots. There would basically be no line to draw. This would just all be kind of gobbledygook. It would look like static, right? Now, that's not the case.
How much more do we have to go here? 1.8, 1.9, 4.10, 4.11, 4.12.
If we're looking here at this plot, we can see that there is some upward trend. So probably what we're going to see is a correlation coefficient that is greater than 0, but definitely not at 1. We kind of see something kind of moderate here. So maybe between those two. So keep that in mind. I'm going to scroll down here to where we actually calculate the correlation coefficient. And we're going to use this, we're going to use Pandas again. So we're going to start with the first series that we're interested in, which is area, square meters. And then we're going to use .cor for correlation. And then we'll put in the second series we're interested in, where we want to see the relationship between. And in this case, it's going to be price USD. and then we'll print it out there at the bottom. And so if I hit Shift and Enter, we can see that our correlation coefficient is 0.58. Let's round it up to 0.59. Let's be optimistic. And what that tells us is that, indeed, if we scroll up here, there is a moderate correlation between area and price. So does the size of a house influence the price of a house? Absolutely, it does. It's not the only factor in determining price, but it is important. Gobbledygook, it would look like static, right? Now that's not the case. If we're looking here at this plot, we can see that there is some upward trend. So probably what we're going to see is a correlation coefficient that is greater than 0, but definitely not at 1. We kind of see something kind of moderate here, so maybe between those two. So keep that in mind. I'm going to scroll down here to where we actually calculate the correlation coefficient. And we're going to use this, we're going to use Pandas again. So we're going to start with the first series that we're interested in, which is area, square meters. And then we're going to use dot core for correlation. And then we'll put in the second series we're interested in, where we want to see the relationship between. And in this case, it's going to be price USD. And then we'll print it out there at the bottom. And so if I hit Shift and Enter, we can see that our correlation.
Yes, I'm waiting. Unsupported type, class list. You just have to have, that's what it is. Some of my numbers seem to be a little off, and I'm not quite sure why. Okay. And we want this to be area metered square. So let's check for the correlation of Well, this makes sense because we do have a negative correlation. We saw that the trend clearly down. So what I'm going to do here, I want to come back over here, and I'm going to go ahead and update my get. I can remember how to do it. Get commit. Okay, let's just manually upload this file back over here. Oh, let's see. Hmm. What is it?
We can see that there's a relationship between area and price across the whole of Mexico. Now let's zoom in on a couple of different states to see if that holds true or if there's a greater correlation or a lesser correlation. Let's take a look. I'm going to go into the notebook here, and the first thing I want to do is I want to subset my data so that I'm only looking from properties that are in the state of Morelos. So what I'll do is I'll create a new data frame. I'll go df, let's see here, and inside I want to put my mask, so I'm going to go df, and I want you to give me only those rows where state equals, and notice I'm using this double equals sign, double equals Morelos. So let's see here, I'll hit Alt-Enter to give me a new cell down below. And let's just check. If I look at df.shape, my original data frame has 1,700 observations in it. And if I contrast that with df Morelos, I can see that I have only 160. And then if I, let's zoom in here, look at df Morelos.head, I can see
we could of course at some point I'm sure we'll get to things like filters and stuff like that and queries. Hey, Augustine, how you doing, friend? Thanks for stopping by. Yeah, I'm actually enjoying the class quite a bit. It's just the right pace. I can get through it. I'm actually taking quite a bit of notes on various command structures and stuff like that. I got, I think I got, I think this current set of exercises goes us up to 1.5. Okay. Then there's an assignment, right? Which is actually graded by somehow or other. We're talking about correlations and stuff, like all kinds of fun stuff like that. Scatter plots. Oh, I must have spelled something wrong here. Oh, nice, nice. Is there 8 modules? Is that what there is? Here's everything in Morales, right? So what are you learning in what did you learn in four? What did you learn in module four?
See that, yep, all of the properties in this new data frame are in the state of Morelos. So, done and done.
Logistic regression and decision trees. Oh, I could use some little logistic. I could use a little regression here on these numbers here for the. I could use a little linear regression, for my scatter plots up there. But but I'm getting close to finishing this the exercises up here. I think this goes up to 1.5. Is that what it does? 1410, 1411. So I'm at 14 what? 9. So I got 1, 2, 3 more sections to go. You know, there doesn't seem to be an easy way to add a linear regression line to a uh, to a matplotlib scatter plot. I actually looked it up on that chat program, and you have to basically calculate the numbers yourself and then plot them. Although I will mention, I don't know if you use Seaborn or not, but in Seaborn there's actually a plot called, I think it's called regplot for regression plot, and it'll plot the scatter plot, then it puts a regression line over top of it. So that's, so I don't know if what they're actually going to show us this here. Let's see now, 4.11. District of Frederico. Wait. What Seaborn is? Okay, all right. I'll get there probably sometime next week. We already did a scatter plot. Using the DF Morales scatter plot, it shows the price versus area. Hmm. Slow and steady. That's mm, let's see if this works. There we go. Seems to be a positive correlation. If I didn't know better here. Wow, it looks like correlation is even stronger within Morales. Let's calculate the Pearson coefficient. Hmm. This is what this video has to say.
Correlation coefficient for Morelos. Is it bigger than for the rest of the country? It's time to find out. Let's zoom in here. I'm going to scroll down to task 10, and let's create our new correlation coefficient. This is going to be some of the code that we've used before, but now we're going to be using with DF Morelos instead of the other data frame. So I'll look at area square meters. I'll do dot core for correlation. Then I'll do DF Morelos again. And we'll be looking specifically at price USD. Price USD. And I can see that the autocomplete gave me a double Morelos here. 2 for the price of 1. I'll remove that. And I'll hit Shift and Enter. And we can see, wow, this is a strong correlation. Yeah, 0.84. That's very close.
So, let's see if this works. Yeah, 0.8, 0.83. That's a pretty positive correlation, I would say. With the correlation coefficient that high, we can say there's a strong relationship between housing price and Morales. To conclude, let's take a look at the Mexico City District Federale. Right? Did I finish this back up here? No.
Close to 1 for this sort of like social science kind of thing. So we can definitely see that in the state of Morelos, in that real estate market, there does seem to be a strong relationship between house size and price.
Okay.
It's time. We've been circling around the center of Mexico for a long time. Mexico City, Distrito Federal. And so now it's time to take a look and see if we see those same types of correlations as we did with the country as a whole, with Morelos, that particular state, and now DF. So let's zoom in here to our notebook and begin our work.
So we should just use this and then change this, right?
Let's see here. We need to create a new data frame. We're going to call it DF Mexico City, and we'll do DF, and then we'll subset that data frame. So I want DF where every state equals, and then it's going to be not Morelos, it's going to be Distrito Federal, Distrito Federal, beautiful, Federal, awesome. Let me just see if this works. Let me run this cell. I'll do Shift Alt below just so I have a new cell. And then I'll do DF Mexico City just to see if I have my observations in there. The shape, 303 houses, beautiful. And I'll do the head, properties, beautiful. Everything is in the federal district. So with that in mind, now that I have this subsetted, let me create my scatter plot and then do the correlation. So let's see here. First things, the scatter plot. I've got an idea. I'm feeling a little lazy. What if I scroll up here?
There you go.
And I grab this chunk of code and I scroll down and paste it in. And then I just make sure that I take Mexico City data frame and I paste it over what was DF Morelos. There we go. And then I just want to create this one. This is going to be Mexico City. Adjust the title. Let's see what that looks like. Awesome. Very good. Excellent. And then the last thing that I want to do is I want to look at the correlation. So I will take, you know what? Let's do the same thing again. I'm feeling a little lazy. I'm going to scroll up. This is like empty calories, guys. Oh man, it's like eating cookies on Christmas Day. I'm going to copy and paste what we had before, paste it down below, and then I'm going to just replace DF Morelos with DF Mexico City and run this. And what we see here is interesting. We can see that the area of a house, the size of a house, doesn't have as nearly a strong correlation. And we can see that visually, so not so much of a relationship between area and price. And then we can also see.
Okay, folks, we're almost finished for this evening. We'll finish this section, and then we'll pick it up tomorrow night with the assignment, all right? So let's come down here. Like he says, we're going to come down here like so. Distrito Federal. let's just do this. District of Federale, very good. Very, very good. We don't need to keep we don't need to keep these notes in the thing because why? Because we've already got it recorded someplace. Let's come back up here just like he says. Okay. And all we have to do is come over here. Hmm. And there we go, my friends.
That numerically, because while there is a positive correlation coefficient, it's not very big. It's 0.41. So, again, it looks like this idea of price and area being related doesn't hold true. Maybe it holds true in aggregate across the entire country, and maybe it's especially true in some states, but it's not true in every state. Very interesting little conclusion here. Congratulations! You just finished the last task of the last lesson of this Mexico housing project. So congratulations. Now, what can you do that you couldn't do before? Well, one, you're a superstar with data frames, right? Cleaning data, putting data into those data frames, moving everything around, doing new calculations, doing group by aggregation work. You're really like a data science ninja. And then you're also really good now at doing visualizations. You can do histograms, you can do box plots, you can do scatter plots, and you can do bar charts. All great ways to communicate, numerical information to the rest of the world. And then finally, you're able to look at the relationship between two variables like area and price using the Pearson correlation coefficient. So give yourself a pat on the back. That's a lot to learn in one lesson. Up next, you're going to be putting all of these tools to the test in your assignment. And I look forward to seeing you all in Project 2 after you finish that assignment. So best of luck, break a leg, kick some butt, and I'll see you all in Project 2. Bye-bye.
And with that, my dear friends, I'm going to bring this session to a close. I'll see you here tomorrow night, 8 o'clock. We begin working on the assignment for the complete. Because once we get to the assignment, that means we have one module down and 7 to go. Okay. So thanks so much for stopping by. See you folks tomorrow.